Welcome in dark core. Looking at the night sky with hundreds of stars in there, it seems to us that they are distributed more or less evenly. It was previously believed that galaxies and clusters of galaxies are evenly distributed in the universe. Sort of like raisins in a cake, where each highlight is a cluster or supercluster of galaxies. But suddenly this slender and beautiful picture of the world collapsed. And instead of raisins, scientists saw giant holes, as if someone in our cupcake picked out plenty of the raisins. How do you like the void the size of 2,953,000,000 light-years? How did these huge spaces form, where there is almost nothing? And what is the distance from us to the nearest so gloomy formation? And the most unexpected question, is there a connection between such gigantic voids with alien civilizations? Holes in the universe were first discovered in 1978 by Stephen Gregory and Laird A. Thompson at the Kitt Peak National Observatory. They are called voids. Scientists soon realized that the structure of the universe is much more complex than previously thought. That superclusters of galaxies are for some reason elongated in the form of threads 163 to 260 million light-years long. And essentially, the universe resembles a giant three-dimensional web or network. Oh, if we would know who wove it. And between the threads of this network, there are just voids, the average size of which is 30 to 50 million light-years. But no sooner have scientists drawn a new picture of the world for themselves, moving from cupcake to the web, than the universe has dealt a new blow. And in 1981, a void was discovered in the constellation Boötes, the size of which was 330 million light-years. And this is 0.27% of the diameter of the observable universe, which today is 93 billion light-years across. Such gigantic voids, and there are many of them, were called supervoids. How did such gigantic voids form? The formation of galactic threads was first explained. To do this, we had to involve dark matter. According to the standard model of the evolution of the universe, galactic threads form and follow along network-like flows of dark matter. It is assumed that this dark matter is responsible for the macrostructure of the universe. Dark matter gravitationally attracts baryonic matter, and astronomers observed this ordinary matter in the form of walls and threads from galactic superclusters. And this easily explains the appearance of voids. Baryon matter, which means stars are attracted to dark matter, the concentration of stars and galaxies near dark matter flows increases, and where there are no flows, it falls. This is very similar to the attraction of iron filings lying on paper in a magnetic field. They are also grouped along magnetic lines and thus these lines become visible, but this explains the formation of voids, emptiness between galactic lines. But how did supervoids come about, whose size exceeds these lines themselves? After all, the same supervoid in the constellation Boötes is a unique area. First, it has an almost perfect spherical shape. Secondly, it is really almost empty. Initially, only 8 galaxies could be found in it. But further observations revealed 60 galaxies in a vast expanse more than 250 million light-years across. According to astronomer Greg Aldering, if our galaxy, the Milky Way, was at the center of the Boötes void, we would have learned about the existence of other galaxies only in the 60s of the XX century, when powerful telescopes with mirror diameters of more than a meter appeared. And the night sky above us would not be so beautiful, dotted with many bright stars. There would be a couple of stars in a completely black sky. Or maybe there would be nothing at all. But if the Earth had managed to be in the Canes-Venatici supervoid, located in the Canes-Venatici constellation and which today is the 8th largest supervoid, then, most likely, we would not even have a couple of stars in the sky. In this vast void, which is 1.3 billion light-years across, there are only 17 clusters of galaxies. Moreover, they are concentrated in a spherical region with a diameter of 160 million light-years. That is, almost 10 times smaller than the size of the entire supervoid. If we find ourselves, for example, at a distance of 600 to 700 million light-years from this area, we will be provided with an absolutely black sky. And for a long time people would not know that there is such a thing as stars. I wonder what kind of worldview we would have then? And yes, flights to other stars would not be on the table for us in this case, even in a very distant future. Fortunately, the distance from this gloomy region to us is approximately 1.5 billion light-years. So we live, albeit on the periphery of our Milky Way galaxy, but still, in a rather busy place. We have about 24 neighbors in a region of space only 3 million light-years across. Considering that the average distance between galaxies in the universe is several million light-years, then in such a huge space as the Boötes void, with a similar density, there would be about 10,000 galaxies. And there are only 60 of them. So how did such an anomalous region form? Computer simulations have shown that such voids could not form in the same way as ordinary voids. Not enough time has passed since the birth of the universe for gravitational forces to cleanse space of this magnitude. Attempts to find an explanation led to the development of a new theory, suggesting that supervoids are formed as a result of the merging of smaller voids. Aldering noticed that void galaxies take on curious tubular structures, and this seems to be an important clue. In addition, he suggested that the Boötes void formed after the merger of smaller voids, similar to how soap bubbles merge into one large bubble. As for the tubular galaxies, then, most likely, these are the remains of the boundaries between smaller voids. It is also possible to assume an even more radical version of the development of events, which has hardly been considered in the scientific literature. So, the Boötes void could be formed as a result of the expansion of a highly developed civilization. In the process of colonization, the bubble of civilization expands in the direction from the native system of civilization, which obscures every star, and then every galaxy, in its path, covering it with a Dyson sphere, that is, a sphere that would absorb all the radiated energy of a star and let it go on the needs of civilization. To a distant observer, it looks like there is no star in that place. This could also explain the rather even spherical shape of the void. Given that the void of Boötes is about 700 million light-years from Earth, and that intelligent life in the universe could have arisen about 4 billion years ago, such an ancient civilization had plenty of time to perform this amazing feat of cosmological engineering. Yes, this is pure speculation, but given the strangeness of the phenomenon itself, such a hypothesis can be considered. More than 40 years have passed since the discovery of the supervoid in the Boötes constellation. During this time, many other supervoids were discovered, and even surpassing it in size. Now the supervoid in the constellation Boötes occupies only a modest 71st place. And who takes the first place? This is the supervoid LOWZ North 13788. We already talked about it at the beginning of this video and its staggering size, almost 3 billion light-years. It contains only 109,066 galaxies. Yes, for such a mind-blowing volume, it really is, only. And now let's answer the last question asked at the beginning of this video: how far is our planet, our solar system, from the supervoid closest to us? The answer is a distance of 0 kilometers. We are in a supervoid. So far this is just a guess. Scientists have found discrepancies between measurements of the Hubble constant, which characterizes the rate of expansion of the universe, using galactic supernovae and Cepheid variables and using data from the cosmic microwave background and baryon acoustic oscillations. In the first case, the Hubble constant was 72 to 75 km s/mpc. In the second, 67 to 68 km s/mpc. It has been suggested that this discrepancy can be explained by the fact that our planet is in a supervoid. Galaxies inside the void experience a gravitational pull outside the void, giving a larger local value for the Hubble constant. This supervoid is estimated to be about 2 billion light-years across, smaller than LOWZ North 13788. It is named KBC Void after astronomers Ryan Keenan, Amy Barger, and Lennox Cowie who studied it in 2013. It is thought to be nearly spherical and contain the Milky Way, the local group, and most of the Laniakea supercluster. But many scientists believe that this hypothesis contradicts other available data and does not fully explain the discrepancy in the measurements of the Hubble constant. So are we in a supervoid or not? And why did the universe turn out to be so inhomogeneous, like poorly mixed and baked dough, lumps in one place, and emptiness in another? Why such a complex structure? What is it caused by? What do you think about it? Write about it in your comments. If you liked this video and it made you think, put like and don't forget to subscribe to our channel. There will be many more interesting videos about our universe. Thanks for watching Dark Core.